Yes, welcome to Chips of Math Physics Cambridge A-Level Math, and we are looking at topical questions. This topic for radians. So we are going to look at various questions on radians as expected by Cambridge specifications, especially exam style questions, and we are using these past papers supposedly for those preparing for this year November international exams. So pay attention to details, and you might require the M419, MF19, that is the list of formula, as they will be needed in some of these calculations. So let's look at the first question, which is number 4. The numbering might not be systematic. So the first question here is about finding the perimeter. I remember when we talked about perimeter in circular measures, we talked about finding the total area of a shape in 2D shape. It could be a rectangle, it could be a circle, it could be a rectangle or other similar shapes that we use to find the area or the perimeter of that particular shape. So here we have the diagram shows a sector ABC is of a circle with center A and radius is 8 centimeter. The area of the sector is given as 16 pi over 3 centimeter squared. The point D lies on the arc BC, as we can see. The point D lies on this arc. This is point B to C, and the radius is B to A. We can see 8 centimeter. So we want to find the perimeter of the segment. So for us to find the perimeter of the segment, we first of all need to look at the angle theta. So if we want to look at the angle theta, how do we find the angle in the given equation? So let's look at how we can be able to find the angle theta. So to find the angle theta, we might need to find the area. So the area of this particular angle relating to radians, we have the formula, and that formula will be given in the list of formula MF19. It is half r squared theta, and we are given the area. The area is given in the equation. The area of the sector is 16 pi. So we are given 16 pi over 3. So we are going to substitute that. So we have 16 pi over 3. This is equal to a half r. In this case, a half is 8 centimeter. So we simply substitute 8 squared theta, right? So multiply this by theta. You can plug this in your calculator as you simply try to find out what your answer would be. So we are going to have 16 pi over 3. This is equals to a half multiplied by 8 squared. This will give us 32. So this is 32 theta. Looking for what is theta, we will simply divide both sides. So we are going to get pi over 6. So it's as simple and straightforward as that. Now we can look at the line. When you look at the line BC, which is the arc, for us to find the line BC, we can look at the arc length. And what is the formula we use for arc length? What is the formula for arc length? So arc length, that is arc BC, is simply arc length. So if we look at the arc length, This is nothing but r theta. The arc length is given by r theta, where r is 8 multiplied by theta that we got as pi over 6. Pi over 6. So this implies, what is 8 multiplied by pi over 6? You simply get 4 pi over 3. 4 pi over 3. Now we can be able to look at the line BC using cosine rule. Now when we look at this line, the line BC, because we need the line BC for us to be able to find the perimeter of the given shape. So it therefore means we are going to apply cosine rule. So the line BC, by cosine rule, we can use a squared is equal to b squared plus c squared by Pythagoras theorem. But remember, here it contains an angle theta. So since it has an angle theta, we are going to include that angle. So it is minus 2 BC cosine of A. Cosine of A. So this is a cosine rule. So what happened is that we are going to have our A squared, in this case is going to be BC squared. BC squared, because we are looking at line BC. This is equals to B squared is 8, so it is 8 squared plus C squared is also 8 squared, since we know that if this side is 8, this other side is also 8. So this is also 8 centimeter, right? So if it is also 8 centimeter, that implies that we're going to have BC squared equals to 8 squared plus 8 squared. Now we have 2 BC cosine of A. So that becomes minus 2 times 8 times 8 again, because both B and C is 8 times 8, then cosine of A. Cosine of A, in this case our theta is A, which is pi all over 6. What is left is simply algebraic. You simply plug this in your calculator and then summarize. So this is equals to 8 squared plus 8 squared will give us 128. So 128 minus negative 2 by 8, and 8 will give us also 128. So this is 128. Multiply this by cosine of pi over 6 will give us root 3 over 2. So this is root 3 divided by 2. Now we can find what is B. Remember, this is BC squared. So for us to find B, we can take the square root. So BC therefore will be the square root of what? It will be the square root of 128 minus, if we simplify 128 times root 3 over 2, this becomes negative 64 root 3. Root 3. So we take the square root of that. Negative 64 root 3. Now we can proceed to find the perimeter. So the perimeter therefore is going to be 4 pi 3. Remember, we got 4 pi over 3. We got 4 pi over 3 when we looked at the arc length, that is the arc of BC, which is given by r theta. So it is 4 pi over 3 plus now what we got in line BC. So it is 4 pi over 3 plus the root of 128 minus 64 root 3. So if you plug this in your calculator, you should be able to get 8.33 centimeter. So this is the required solution for this question. The next question, the diagram shows a sector OAB. We can see OAB with an included angle here, theta radians. So angle AOB is equal to theta, and OB is equals to AB, which is equals to x. So we have OP, so OP here is equals to AP. OP is equals to AP, and all this is also equal to x, as we can see x on this side and even x here on this line OP, and on the other line PA or AP. So what we are required to do is to show that the arc length AB is equal to 2x theta cos theta. So what are we supposed to do? So now we are told that this line here, we are told that OP is equals to AP and it is equal to x, and we are also told that this OP is equals to PA or AP. So conceptual understanding, what do we know? We can actually try to sketch, if it is equal, we can have a triangle from here up to P, right, such that we can even call this M or any number or value. This is forming a right angle triangle, and we can extract this triangle from here. Let's do that. If we do that, we are simply going to have a smaller triangle. Just a minute, let me pick a different line instead. So let's have this triangle. Let's have this triangle in this case. So we have this triangle. So here we can have theta. So this is theta. This is O. Since we call this M, so we can say this is M, and then this is P. Of course, it is forming a right angle triangle here, so it forms a right angle triangle here, and this is our X, right? So we are told to show that the length AB is 2x theta cos theta. So cosine of that angle theta in this new triangle is going to be what? Is going to be OM that we have. So we have OM, divide that by X, right? So it is OM divided by X. And if that be the case, OM therefore is going to be X cosine of theta. X cosine of theta, if we multiply both sides. This is like similar like divide by 1. So we have OM to be equals to X cosine of theta. So what will be OA therefore? OA, when we go back to the original image, the original shape, OA, in this case, OA becomes what? OA is going to be 2x cosine of theta. 2x cosine of theta. So our arc length, we know that arc length, arc length is given by r theta. So if arc length is given by r theta, this is equal to 2x cos theta, 2x cos theta, or theta cos theta, the one we are given, multiply this by theta, right? and this is required solution. We are simply trying to prove that the given solution is correct, and we have shown by simple illustration. So this is the required solution. This and this are the same. Now let's look at B. Find the area of the shaded region APB in terms of x and theta. The shaded region is this part, so we want to find the area of this shaded region. Okay, so for us to find the area of that shaded region, let's look at sector OAB. If we look at sector OAB, it is given by a half multiplied by, because there is an included angle, so we will use 2x cos theta. So we have 2x cosine of theta, then square this, multiply that by theta. Right, so this becomes a half multiplied by 2x cos theta squared. If we open that up, this becomes 4x squared. Then we also have cos squared theta. This is cos squared theta, and then multiply this by the theta outside, such that if we simplify this, a half can go into 4, so we are going to have 2x squared theta. So it is 2x squared theta cos squared theta. So this is a sector OAB. So now we can look at triangle OAB. We can look at this triangle OAP. Triangle OAP. So triangle OAP, we are going to also use the area of a triangle formula. So the area of this triangle OAP will be equal to a half. So it is a half multiplied by x, because one side of it is x. We can see x on this side. So it is multiplied by x, because we know formula for triangle is a half base and height. So x, we take x, multiply that by 2x cos theta. So multiply this by 2x cosine of theta. Then multiply that by that angle. So it is sine theta. Sine theta. Then we can simplify this. This becomes x squared. So we are going to have x squared sine theta, x squared sine theta cos theta. Correct. So area of we can now look at area of ABP. Area of ABP. ABP, which is the shaded region that is required. So the area of the shaded region ABP will be 2x squared, then theta. Then we have also cos squared theta minus, so we are simply taking the sector OAB, that we got 2x squared theta cos squared theta minus the triangle OAB. So this triangle OAP, so it is minus x squared sine theta cos theta. If we simplify, we can factor out x squared, because we have x squared and x squared. So we can have x squared cos theta outside, such that we can have 2 theta cos theta minus sine theta, and this will be the required solution for this question. Let's proceed to the next question. The diagram shows a sector AOP. This is AOB, which is part of a circle with center 0 and radius 6 cm, and with angle AOB is 0.8 radians. The point C on OB is such that AC is perpendicular, and we can see AC is perpendicular to OB, right? So the arc CD, the arc C to D, this arc CD is part of a circle with center 0, right? So where D lies on OA, D lies on this line OA. So we are supposed to find the area of the shaded region. This small area here, we are looking for the area of the shaded region. Again, we can extract the triangle OAC. We can extract the triangle OAC from the whole image. So if we extract that triangle, we can have another smaller triangle. Let's have it here. If I draw another smaller triangle here, and then this is according to the given information that we have, we know that AOB, so this is A, and we can call this AOC. This is AOC. So this is 0.8 rad, right? 0.8 rad. So we can look at cosine of this angle. Cosine of this angle. Again, this takes you back to one of those trigonometric rules. It has a mnemonic. I want to believe you still remember the mnemonic SOHCAHTOA. So if I have SOHCAHTOA, so this is SOHCAHTOA, where S represents sine. So sine is opposite over hypotenuse, and then we have cosine. Cosine is adjacent over hypotenuse, and then we have tangent, opposite over adjacent. So this is SOHCAHTOA, and from here we can see opposite. This is opposite, and we can look at these two sides, and we can decide the longest side is always the hypotenuse. So we can call this our hypotenuse. So if this is opposite, this will be adjacent. So you can look at that, and then you are able to be able to decide if that angle is cos or if it is sine. So in this case, this is cos of this angle, 0.8 rad. So if it is cos of this angle, what is so it means that cosine of 0.8 will be equal to OC divided by 6 that we have. Remember, we have 6 OC, the distance from here to here. So it is 6 centimeter. So this is OC. OC divided by 6, right? So if we divide that, we can find what is OC. OC is simply going to be 6 cross multiply, so it is 6 cosine of 0.8, right? You can just plug that in your calculator. You should be able to get 4, this is 6 cosine of that, so it should be 4.18. You use your calculator to confirm that. Now we can look at the triangle. We can look at the triangle OCA. Triangle OCA, we know the formula of finding a triangle. So if we want to find a triangle OCA, so triangle, area of a triangle, so we are looking at triangle area of OCA. So the triangle area of OCA is going to be given by a half. Multiply this by what we already got, which is 4 point, because we know it is multiplied by base and height, 4.18, and then we have 6. Multiply that by 6, this distance here. Then the included angle is sine 0.8. Sine 0.8. Plug that in your calculator. You should be able to get 8. So this is equal to 8.996 approximately. Now we can look at now area of sector OCD. So area of sector OCD. So area of sector OCD will be given by a half. Then based by height, this is 4.18 squared. Multiply that by 0.8. So this will give us 6.989. Now we can take the difference among the two of them. So the difference will be OCA minus OCD. So OCA we got 8.996 minus OCD 6.989. Right. Plug that in your calculator, you get 2.01 as the required solution for this question. The next question is here. The diagram shows a chord going around So it is going around a pulley and a pin. The diagram shows a cord going around a pulley and a pin, as you can see. The pulley is modeled as a circle with center 0 and radius 5 centimeter. The thickness of the cord and the size of the pin P can be neglected. Again, another thing to note, conceptual understanding, it can be neglected. If it can be neglected, the pin is situated 13 centimeter vertically below O. Look at the image again, you can see vertically below O. Point A and B are on the circumference of the circle, such that AP is and BP are tangent to the circle. Yes, we can see AP, we can see AP, and we can as well see BP. They are all tangent, and you know what tangent means? The line that touch the circle at one point. So they are tangent to the circle. The chord passes over the major arc AB of the circle and under the pin, such that the chord is tau. Now we are supposed to calculate the length of the chord. We are supposed to calculate the length of the chord. Interesting. So what do we know from the given information? what do we know from the given information? We can look at the angle. We have angle AOP, and we can look at the length of AP, and we can as well try to subdivide this. Let's say we have this angle theta here, what we have here, from here to here, so this is theta, right? So we are looking at this theta from this center AB, so we have A to B, so this is showing us theta, right? Plus now this triangle that is connected by a tangent line, so we have this tangent line joining the circle from this point. So we can call this, so this is A, P, and then B, right? So what we need to do is to extract this other triangle. If we extract the triangle there, if we extract the triangle, then we are going to have A, PO. We extract this part of the triangle. You can see it's forming two triangles. Let's extract one part. So this side we can call, this is forming a right angle triangle. We can call this angle, since this first one is theta, we can call the second one alpha, right? If this is alpha, we are told this side is 13, so this is 13. It is 13, and then this side is 5. So what will be our angle AOP? Angle AOP, that will be using the cosine rule. This is cos of this angle alpha. It is cos of alpha is equal to 5 divided by 13. So if we find alpha will simply be 1.18. 1.18. Now, what will be the length of AP? So the length of AP will be 13 squared, which is equal to, so we have 13 squared equal to 5 squared on the other side, plus AP squared, because we don't know what is AP squared. Then to find what is AP, we will simply take the square root of what? 13 squared. Now this crosses, it becomes minus 5 squared, which is 25, and if you simplify this, you should be able to get 12, right? So the major arc therefore, the major arc of AB will be equal to that angle. So this implies that the angle theta is equal to 2 pi. Remember the equation of the circle. 2 pi minus 2, multiply this by 1.18 that we got earlier on from the angle alpha. 1.8, and then simply put this in your calculator. You should be able to get 3.93, and we know the formula for arc length because the question is asking for arc length is always given by r theta. So r, we have 5 multiplied by 3.93, so we should be able to get 19.7. So the length therefore of a chord, the length of the chord, the length of chord will be AP plus BP plus arc length, that is the arc of AB. AP we got 12, it is 12 plus 12 plus now 19.7. So this is equal to 43.7 centimeter. Required solution. So here comes the next question. The diagram shows a metal plate ABC, in which the sides are the straight line AB and the arcs AC and BC. We have AC, BC as the arc. The line AB has length 6 cm. The arc AC is part of a circle with center B and radius 6 cm, and the arc BC is part of a circle with center A and radius 6. Find the perimeter of the plate, giving your answer in times of x. So we are looking for the perimeter of the plate. Okay, we can draw line of symmetry here, because if we are told that this is a metal plate ABC, we can have some line of symmetry from there and try to have another line of symmetry to give you 2 lines of symmetry that way, such that we can extract this triangle and have a triangle outside. So if we extract that triangle, we will have this 6 cm. So it means this is 6 cm, this is also 6, and this is also 6. It is equal. And according to the information we are given, we can look at equilateral triangle. This is an equilateral triangle. All sides are equal, right? All sides are equal. So it means here is pi over 3. Here is also pi over 3. And here is also pi over 3. All sides are equal, right? So the arc AC is going to be what? We can look at the arc AC and the arc BC, and that of BC. So arc length will simply be what? We are given by r theta, where r is 6 multiplied by pi over 3. Right. So 6 multiplied by pi over 3 is 2 pi. So the perimeter, therefore, now we can go ahead and find the perimeter. The perimeter is going to be equal to AB plus BC plus CA. We know AB is 6 plus BC is 2 pi that we got, and then CA will also be 2 pi because they are equal. So this will be 4 pi plus 6. 4 pi plus 6 centimeter. That's the answer to the question. B. Find the area of the plate, giving your answer in times of x and root 3. Area of the plate. Now let's draw the triangle again, the one we extracted. We extracted the triangle here, and we know that this is 6. If we are looking at the plate the way it is, we can have a curve. We can have a curve. Trying to expand this a bit. Let me take, can have a curve this way, something like that. Trying to draw the plate the way it is here. Right. So area of the segment here is going to be what? So let's look for segment. So this is a segment, and we can actually find the area of this segment. So area of this segment is going to be equal to area of sector. Area of the sector minus area of triangle. So for you to be able to work on this particular radians, you must have full knowledge of the functions, radians, and trigonometry. Area of sector minus area of that triangle. And then we are also going to look at area of sector is ABC. So ABC. So the area is going to be a half base by height times c squared times pi over 3 that we got. If you simplify this, you should be able to get 6 pi. Now, if that is 6 pi, what is the area of triangle now? This triangle ABC. Let's take this up. So, area of triangle. So, triangle ABC is going to be a half times 6 times 6. Sine of that angle is sine pi over 3. Right. And this should be able to give us 9 root 3. Now, area of segment. Area of the segment. Sorry about that. So let's look at area of we are looking at area of segment, because this is area of triangle, 9 root 3. So now area of segment. This is going to be 6 pi minus, remember we said that area of segment is going to be area of sector minus area of a triangle, and the area of the sector will go 6 pi, so it is 6 phi minus 9 root 3. Now we can now look at area of the plate. So area of plate is nothing but triangle ABC. The triangle ABC plus 2 times the segment. 2 times the segment. So this implies that we are going to have 9 root 3 as area of a triangle plus 2 times segment, which is 6 pi minus 9 root 3. Simplify 9 root 3 plus 2 times 6, 12 pi minus 18, 2 by negative 9, 18 root 3. This will give us 12 pi. So this is 12 pi minus 9 root 3 as our final answer. And you can leave your answer in correct units, centimeter squared. Right. So basically this paper is all about finding area of the sector, area of the triangle and all that. Conceptual understanding. Test your understanding with this question 8 and question 9. Those are the 2 questions remaining, and I will be leaving the answer in the link below the video for you to check your understanding. There are similar questions that we have just done on how to find area. Like here we need to find the angle OBOC. Angle BOC. So again, it takes you back to what you know, conceptual understanding. Look at a given triangle, extract the triangle out, find the area separately, and then you are able to solve. So see you in the next video.